Any doubt in the last session that you have? Okay. So you tried anything or you will try today? Okay, no worries. So today, we'll see some, Python advanced concepts. Okay, so today we'll see some that would be used in pandas, as well. Okay. So let's start with list comprehension. Are you aware about this list comprehension? Okay, so let me show you. So let's say let's deal with Python list. So only the simple data type, that is Python list. Okay, let's say this is your list 1 2 3 4 5. Okay, or let's say your list is, you can also use the range function. You have used this range function. Okay, very good. So let's say you have 100 elements in your list. Okay, now you need to, let's say, find what are the elements in your list that are even. Okay, so how will you do that? Okay, let's say you use for hmm, hmm, or we need to, let's say, create another list that is just having the even element. Hmm? Hmm? Yeah, this is done. Now let's see another way to do this. Let's say I want to create a list. I'll use this square bracket. So the square brackets denote list comprehension. Okay. Now one way can be hmm, item for item in L if item mod 2 equal to 0. Let's see first if this is working. Yeah, let's see the time. Let's say now you had 10,000 elements. Fine. Now you first see what is the time that is changing. Let's see. Let's create even more elements. Now we have how many? Around 10 lakh elements. 1 million. Now let's see. Okay, this, let's create something that is even a bit more complex so that we can, understand this thing better. So let's say mod 2 you are doing, or this we are appending in L. Let's do this, and let's do this here. You see, time for this has increased, but time for this is nearly the same. So this is why we use list comprehension. Okay, this is more efficient when doing, when looping over any list in Python. And the syntax is like this. So you create square brackets, okay? Then you create a loop for item in L, okay? Whatever list you want to iterate over, you create a loop over that. And if you simply provide item here, so what this would return is, this would return, let's create a small list of 10 elements. If you just do it like this would create a list of every item that is inside L. Now if you want to do some operation, let's say item to the power of 2, you can do it like this. So you see every element is squared. So this is how you use list comprehension. Now if you want to also do some condition, so you can do it like this. If item mod 2 is equal to 0, so basically it will run over this loop, okay, and it will check for this condition, okay, and then whatever item, you know um, validates that condition, passes that condition, it would do this operation on that item. So now if you see, every even element has been squared. Fine. If I would have done like this, so every odd element would be squared. Okay, makes sense. This is known as list comprehension in Python. So there are three parts. I'll show you here. One is the output. Okay, this is the output part, whatever you are getting as the output. Then you will have a collection. Okay, so this is, you see, is a collection for item in L, or you can say a loop, and then you have a condition. This is the syntax of list comprehension. Make sense? Okay. And using this, you can do, uh, or why this is faster than the original one. That also I'll explain. Because see, in original, what you are doing in this loop, you are first iterating, then you are checking the condition. Okay, then you are appending every element. But in this scenario, you don't need to append. Automatically, it is being formed inside a list. So that's why this computation is same. Okay. So this is known as list comprehension. Okay. A way to loop over your list, do some conditioning over your list, and all different. Fine. Okay. Very good. Now let's see some functions around list in Python. Okay, let's see some functions that we can apply to our list in Python only. Let's try those. So let's say we use there is one. Have you used map function? So let's see this. So you see map, and what you can do is, this is the function that you can apply, and this is the iterable. Okay, iterable is your list, your tuple, your dictionary, or anything, whatever is iterable. And this is the function that you can apply on the iterable. Okay, like, let's say, what function can we apply? Let's say we have our list only. Okay, and okay, before this, let's see lambda function. So that would be okay. That also would we will study. First, let's take a simple list. I'll show you 1.1, let's say 2.2, 3.3. Okay, let's say we have this list. Okay, and we want to apply the round function on this list. Fine. So map returns a object of map kind. So you need to convert this into a list. You see, everything got rounded. Make sense? So this is how, let's say if you want to apply some function, some pre-built function, so you can apply directly. I'll show you lambda functions also. So you can use map like this. Okay. Then you can also use filter. You can also use reduce. But before that, let's see lambda function. That is very. This is very important concept in Python. Okay. So first, let's see lambda function. Then we'll return back to map. Okay. So lambda function means, this is also known as anonymous function. You would have studied about anonymous function. है ना? So similar to anonymous function, this is known as, here we use lambda function. Okay, here also there is no name of the function, like in anonymous function there is no name required. Okay, and this is a single line function. Let's say you have lambda x, and you do x to the power of 2. Okay, let's say this is your function. Okay, now whatever you pass, I first show you the syntax, then we'll see how it works. Okay, you see, this is the function, only this much. So this is, first you use the lambda keyword. Okay, then you provide whatever variables you want to use, or the function arguments. Then you provide what operation you want to do on that argument. Okay, after the colon. So here, if you see, I have signed f as this lambda function. If you see the type of f is function. Okay, now if I use this bracket like we use for any normal function, and we provide any argument. Okay, so you see this argument would be converted, this is same as x, so x would be equal to 4 and 4 to the power of 2. We can also do f of 10, so then what would happen? 100, you know. This can be even a bit more complicated. Let's say you have x, y, and x to the power of y. Now what you can do, you can pass two arguments. What? 4 to the power of 2, 16. Fine. Or f of 10 to the power of 3, then it becomes 1000. You see, we can also use two variables or any number of variables for that matter. So this is known as lambda function. This is very much used whenever you will be working with Python. Okay, so we started with list comprehension, then we have reached lambda function. Now we will see in map that we saw earlier. Earlier I was using this round function. You know, this though is an inbuilt function of Python. If you will see round, you see this is an inbuilt function. Round number and number of digits you want to round. If you don't want to use the inbuilt function, so you can also use the lambda function. How? Let's say lambda x to the power of 2, and here is your list 1 2 3 4. So now what would happen? Map would do what? It will take each element or item from the list, and it would pass this every item to this function, like it was happening in round, है ना? In round what happened? Every element of the list was rounded, है ना? So round function, every element was passed as an argument to the round function, and the result was returned back as a list. Similarly, we can also do using this. We just convert this. So you see, if you want to make this simple, you can also do like this. L is equal to, now use it. Fine. Make sense? And this can even be, this is to lambda function. For map you can even pass any default function or any function that you create also. Let's say you create any function, define f, okay, and let's say you create this function. Tell me how we create prime function, prime number, how we calculate. How? Let's say you want to create a function. Sorry, for loop. For I, from what? In, what is L? No, you are provided a number. Now you want to return whether this number is prime or not. So for I in, num to would be a single number, na? You will pass it like this, prime 10. It would return whether 10 is prime or not. So how you can loop over this? Very good. Range of num, and usually for prime we take it till by 2 only. You know? If so, prime, let's say, or not is equal to, let's say, true for now. If num mod I is equal to 0, then this becomes false. Return prime or not. Make sense? Now let's check. 10 would be what? Float object can be interpreted as an integer. Okay, let's see. Okay, we will need to do like this. 10 I'm providing. 10 divided by 2. Num mod I. Okay, it's starting from 0. Na? That's the issue. From 2 it need to start. Fine. So see what I made change. This can be, so you do you know about this sign, double division? Okay, see in Python, like you do, let's say 4 divided by 2, what would, also let's say 4 divided by, or let's make example 10 divided by 3, what would this become? 3 point something something, 3.333333. Now, if you use this double division, okay, this would cut off the, so this would give you a rounded result, okay, the floor value. So this would directly give you the floor value. You could have also done this like you would do round, and then one way is doing this, or you can directly use this double division. Fine, makes sense. Double slash operator. Actually, this is equal to, this is known as floor division. Fine, and range. I'm starting from two. So otherwise, what it was doing, it was starting by default. It starts from zero. There is no need to divide by zero and check. That's why I'm starting from two. So if you see by default, if I do range 10, so this would give me, let's convert this to a list. So this would give you 0 to 9. But if I start from 5 and I want to go till 10, so like this also you can do. And so now let's check for a prime. Okay, so this gives me this is prime. And this is correct. Now let's use map function and implement this over every element in my list. Okay, how? Let's say you have a list, you have a range of 100, so you have 100 elements, and what you want to do, map your prime function to this list. Okay, let's convert this to a list. So this would return true false true false. We don't want to be returned true false and true false, we want the exact number. So here you see for 100 elements it has returned whether this element is true meaning prime, false meaning not prime. But we don't want true and false, we want the exact number. So what we can do, if prime or not, okay, if this is true, then return what, the number. What number was the number, the original number. And if it is not true, then don't return anything. Fine. You see, now if I am doing prime 13, it is giving me 13. Now if I am doing prime 10, it is giving me nothing. And now if I do this, okay, this is one issue, that we are being returned none. So it is actually appending none for the non prime numbers. So that is one thing which we can solve. Four, why it is returning, because okay, we are starting from two and we are going till num by two. So 2 and 2, okay, that's why it's not so num by 2 plus 1 usually we do. Now it would return 4 as a prime number. Num by 2, because 4 by 2 is 2, and if it is starting from 2 and it is going till 3, this should go till 3, then this should return fine. Okay, let's check why is it still it is returning 4. You see, now it is not returning. That is correct. No? It is not returning anything. Fine. So you go from num by 2. So if you put 4 here, okay, let's say num is 4. So what would be the range value? 2 till, starting from 2 and it will go till, very good. So earlier it was going till 2. So starting from 2 and going till 2, because the last, the end, we go, range automatically goes to 1 before the end value. 1 minus whatever is the end value. So when we did this round 5 to 10, you see it went only till 9. That's why 4 was what not being covered correctly. Okay, makes sense. Very good. Now, what we can do is very good. Let's see now another thing. Let's see. Uh, we have got list from this. Okay, let's save this list. Prime list. Okay. Now, what we can do is we can connect the filter method. Okay, like there was, map, there is also filter. What is filter? Similarly, the same syntax, you provide a function lambda x, let's say x is not none, and you provide the list, prime list. You see, now we have got all the prime numbers. That why we are getting, because we have ideally we have, we need to provide this whatever filter for one and all those things. So that is not an issue, you for best result you can start from 2 only. Our aim is to understand map and filter. Okay, prime function, perfect one, we can, you make using those things. But yeah, now you have understood map, and you can use your own function also inside map. What would happen, this function would, every element in this list would be passed one by one as an argument to this function. Similarly, you can also do a filter. In filter also you can do same thing. You can provide a function, and every element would be passed as a, list. Now the benefit of filter versus map is, you know now initially I used map, then none was received, है ना, and all those things. I could have directly used filter also. How? If I directly use filter, I won't have to do map. If I use just prime here, okay, and I used L here, and here if I just return prime or not, okay, and if I just use the filter function, so you see directly it returns all the prime numbers. So if the result is true of this function for that element, then this element would be filtered. This element would be returned. Otherwise, it would be filtered out. Okay, this is how filter works. And for map, whatever is the function, it applies whatever is returned, that is added as a value to the list. Here the list is filtered, here the function is mapped to every element of the list. Whether you want to, do a exponential or a division or anything. So that is map and filter. Fine. Any doubt in this? No. Very. Now let's see some applications of map and filter, so that this becomes more clear to you, how better we can use map and filter. So these are also known as higher order functions. Okay, so let's say you want to apply some, you want to add 3 to every element of your list. Okay, or you want to add 5. So you will use what? You will use a map, and you will pass your list. What would this return? See, every element has been added with 5. Okay, so you don't need to loop, use for loop, go to every element and apply this, this x is equal to x plus 5, or item is equal to item plus 5. You can directly use map. Or if you have a list, again you have a list, or and you want to just filter that list, you want to check whichever is the, you know even number. So lambda x, fine. So like this you can directly use filter also. Fine, this makes sense. Okay, now we also have one reduce function. Okay, what reduce function does is, this is a bit typical, in the sense that what it will do is, let's say you have lambda a comma b, and you do a plus b. Let's say you have a list. Okay, l is equal to, let's say, 1 2 3 4 5 6 7 8 9 and 10. Okay, now if you want to find the sum of this list, okay, sum of the elements, then what will you do? Ah, so we can use reduce and lambda a comma b, okay, a plus b and l, and reduce by default should not be there, so you need to import this from func tools input reduce, and you see you have got the result. So this is sum of this. So reduce function does what? I'll show you. Let me put it here. Okay, let's take this. So reduce function will work like this. So let's say you have one, two, three, four, five elements. Okay, let's take these five elements. So A, this would become this. B would become this. Okay, then we will do a sum of this. Okay, sum is three. Now A would become this and B would become this. Then you will do a sum six. Now A would become this six and B would become this four, and you will do a sum, so 10. Now A would become this and B would become this, so 10 plus 5 15. So this is how reduce is actually. So you see you have multiple inputs, and it gets reduced to a single output, as the name suggests, reduce. So this kind of thing you can apply. Even you can do a multiplication, it will multiply all the numbers and give back. Okay, whatever, let's say 1 into 2, then 2 into 3. Okay, 6 6 into 4, 24 into 5, and so on. Okay, this is how, not equal, so plus. So these are known as higher order function in Python. Okay, make sense? Very good. And in this you can provide any iterable object, like we did it with list. We can also do it with uh, numpy array. We can also do it with, let's see, let's try for once with numpy array. Let's say you have this list, you have arr is equal to np dot array 1 2 3 4 5 arr, but numpy is not defined. Import numpy as np. Numpy has been imported as np. See, you can also return this as a numpy array. Array and map object, but this you'll have to save and then actually run. So let's use it as a place. So I'll also tell you about generators and all those things in a later class. Then you will be able to understand why at some times you need to convert it into a list, so to see this, and at times you just get the map object. So we'll see that in later class. But yeah, this can be a numpy array also, this can be a panda series also. Let's say import pandas as pd. Pdx is equal to what? Let's say pd dot series. Okay, now you have, let's say, dictionary name. Yes, let's say you have this name is Alok, Sushant, Rajiv. Okay, so you have this panda series. Now you want to apply the map function. Let's say you want to apply filter, and you want to check all those names that start with, okay, what is this, all those names that start with a. Okay, so one very easy way is used to use the filter function. So how you can do, see, list uh, filter lambda x if x at 0 is equal to a, then return, and you just pass your this. What is this? X dot 00 PDS name. PDS name. Fine. So you need to pass the index also. If you just pass PDS, so it will return like this, है ना? It returns the index and the value. So we need to just get all the names. Fine. So this is how you can work with strings, float, any data type. Fine. So this is very powerful. Filter, map, and reduce. And these are faster also as compared to your loops. These are faster also. Okay, because they have been in below, like they have been implemented as such that they are faster than loops. So what happens when you will write loop, that loop would be converted into a lower programming language, like C or anything, and then it would get executed, and these directly get converted to that lower languages and they start getting executed. So these are a bit faster also. Fine, makes sense. Okay, now we were, filter is done, map is done, this is done. Okay, this is also done. Very good. Now let's see the uh, generator generator objects. Okay, so are you aware about what is a generator in Python? Okay, so you are aware about lazy evaluation. So what happens at times, you know, let's say you have uh, 2 million records. Okay, so what happens if you store that 2 million records in your list? Okay, then what would happen is, then the memory would be consumed a lot, you know. If you store these many records in your list, then a lot of memory would be consumed. But what you do, if you don't store it in your list, if you use generator kind of object, so it won't store everything at once. Okay, it will keep on calculating one by one. Like I'll show you, let me show you some example. So are you aware about this Fibonacci series? I know you have implemented that. So let's try. Tell me how to implement Fibonacci. Yeah, till whatever limit I want to print that. So how to start? Let's say let's say A and B are two elements. One is 0, one is 1. Now for range would be starting. Let's say we go to till limit, two till limit, limit plus 1. Let's say now what we will do, sum is equal to A plus B. Okay. And what we will print, let's print A comma B, and let's also print here, let's say A comma B. Okay, let's see what is the result. Fibonacci till 10. So you get, what are you getting? 0, 1, 1, 1, 1, 2. So you don't need to print A comma B. You can just print in same line you want to print. Just a second, I'll show you that. But first, you see, you don't want to print A comma B both, because then what would do 0, 1, 1, 1, 2, 2, 2, 3. So twice they are printing. So you should just print 0 1 1 2, so 2 1 3 3 2 5 5 3 8 है ना. This now makes sense. You just need to print b, and for printing in same line you can use this. Let's say separator would be something that separates these two. Okay, that comes in between. By default the separator is space, so I change the separator to comma. And then end, by default the end is new line, but now I'm using the end as comma. Right? Using, by changing this end parameter, you can override the backslash n or a new line. Okay, so now this is one thing. Now let's say the same thing if we want to do using a generator object, then what would we do? I'll show you. Fibonacci limit. Okay, and let's, yeah, how many elements we want to print? See, 1 2 3 4 5 7 8 9 10. Currently we are printing 11, so we can do it till 1. Fine. So range would go from, so how many times we want to do this sum of previous 2 is equal to 1, sum of previous 2 is equal to this one. So that is limit. So now we will do a comma b is equal to 0 comma 1, and while let's say a is less than limit. Okay, now this will yield a comma b is equal to b comma a plus. This is a shorthand for doing this, you know. This is possible in Python. Okay, this I'll show you. Now what is happening is when we use this generator. So this is how we use generators. Okay, until and unless, I'll show you. Let's do, let's say x of Fibonacci, and we provide the limit of, let's say, 10. Okay, ideally what would have happened if we would have used this function, so we would have got the result है ना, in one go. But here if you see this x, you see what it is saying, this x is a generator object, because there was this yield keyword inside the function, so this becomes a generator object. I'll show you. So if you want to calculate the value, so you see you'll have to use this next function. Now let's first see, then you will understand. Let's see next x. So you see 0. Again if I run next x, so you see 1. Again if I run, again 1. Now 2, then 3, 2 plus 3, 5, 5 plus 3, 8, 8 plus 5, 13. But now it has stopped because the limit was given. Okay, you have got the stop iteration because of whatever was the limit. Okay, so what happens when you are using this yield and generator thing? So ideally, if you use, you don't use yield, so the entire thing gets calculated at once. Okay, this entire function would run at once. But when you are using yield, then what would happen? The function execution would pause here and will resume on executing next. See, I'll do it again. Currently, you see there is nothing in the memory. Okay, there's nothing in the memory. When I will run next x, then this would run the first time. So when I'll run next x, first time it got run. When I'll again do next x, again it will get run. Fine. So this is how we use yield function. So what is the advantage? That let's say if your limit was this, What happened if your limit was this? Okay, if your limit was very large, that it cannot fit in memory only. If I run this function with this limit, what would happen? And my system will crash, है ना? My system will crash because this much computation, if this will start doing, or let's say if you have billion records in your data set and you directly start executing things, then your system will crash. So that's why we use generator objects. Now if you see I run this, it runs fine. You see, next, next, next. This I now I have executed this, okay, but until and unless I run, so one by one it is actually getting me the results. Okay, rather than doing everything at once, one by one it is getting me the results. So that whenever data is very large or the computation is very large, so we use yield functions to do computations or to process data in chunks. Okay, this is why that map and filter we were seeing, they were directly not returning results. We had to use this list, है ना? You see, we whenever we do, let's say if we do just this map of lambda x plus 2 and let's say 1 2 3, so this would not give me the result. uh, we need to by converting it to list, what happens, it no, what happens is this generator object is run, and you get the result in one go, rather than going it again and again and again. Yeah, map is actually also doing this kind of thing only. It is also doing like this. Make sense? No, you cannot use next. You can use this print iterator, I think. Let's try this. Print iterator, we have to import print iterator. Let's create this function. Yeah, we'll have to iterate over this one by one. You see? So this is the iterator, and one by one it will create the results. 3 4 5. Meaning, I'll show you also. Let's directly save the map function. Okay, let's say m. Okay, this is the map function. Fine. Now what you can do, if you will directly do like this map dot next. Okay, map, it will say map has no object as attribute next. So because this is, so what you I can do, item in m, what you will do is print item. Like this you can get the results. Make sense? Or directly you can convert this m into, now you see one more thing. If I run this, you see nothing is being returned, because this isn't generator object, है ना? When you reached the last next, है ना, when that stop iteration occurred, उसके बाद anything would be returned. So similarly, you see, same thing this is also doing. You can only do this once, but once you have iterated over this entire map object, that next internally it has reached the end, then again you cannot do this. This is only a one time thing. For doing it again, you will again have to create this object, and you will have to again print this. But once you have iterated over this object, then you cannot. Okay, make sense? Okay, very good. So similarly with you know that also your what we say filter, same thing we follow in filter also. So any doubts here, because these might be pretty new things. Any doubt? Okay, very. And like we did it for Fibonacci, है ना? You understood for Fibonacci how what we are trying to do, what we are trying to implement, है ना? Very good. So we can like map is actually a custom this is a implemented iterator, like I showed you. This is known as, like I told, generator, and this is how we iterate over a generator, right? Now I'll show you one very interesting thing. Let's say you want to make your own iterator. Like in map, we get returned a map object. Now you see how object oriented programming can be used. Let's say you create a class prime, custom iterator. You create a class prime, you define the constructor self. This I told you, है ना, self. Let's say self dot num is equal to 1. So we are actually implementing an iterator over the prime numbers. Okay, self, and let's say also give a limit. So how many times we will actually iterate, or how many prime numbers should be there. Okay, or let's start with a simple thing so that you don't get confused. Let's just take is this, and let's say define is prime. This we had already seen. Okay. Self num for I in range. Let's say we start from 2 and we go till num by 2 plus 1, है ना? If num mod I is equal to 0, then what would happen? We return false, else we return true. See, this makes sense. Now we define our next. You see, now we are defining our own next. What would this do is self dot num plus is equal to 1. So whatever initially it was 1, है ना? Initially this was 1 when we passed, when we just initiated the constructor. Now what we are doing is, whenever next would be called, we will go whatever is the current value plus 1. Let me implement this, then this would, while not self dot is prime, self dot num. I'll first, let me implement this, then it will make sense. This plus is equal to 1 is clear. Why why Okay, in Python we do like this, no? Okay, very good. So now see, this is our custom iterator. Now let me just create an object of this class. Okay, I created an object. Fine. You see, this is what, this is a object of prime class. Now what I will do is p dot next. What would next do? See, it will start from 1 and it will go to 2 as soon as I run next. You know, because why I am doing this, because one, I know one I'm not including in prime, I'm starting from 2 only, so that's why I did this. Now while not, it means while we don't get a prime number, while self dot num is not a prime number, keep on increasing self dot num. So initially it would be 2. 2 is a prime number or not? So we will get true from this function. So this will stop and it will return self.num. Then it will go to 3, 3 would also be returned. When it will go to 4, then what would happen is 4 is a prime number. So this condition would not be true. So you see, while not true, so while not true becomes false, not true becomes false. So that's why it will increment. So now let's see p dot next. You see, initially this becomes 2. Now if I run this again, this would become 3. Now if I run this again, what would it become? Very good. So you see 5, 7. So this is how I showed you. This is a custom iterator you can also create. You can also loop over this for element in the next. Let's see this uh, range of, let's say, 10 print p next. Okay, you see we got 10 prime numbers like this by running our custom iterator. So these are known as iterators or custom iterators. You know, like Python and all those, Python, I'm saying map and all these things. List is what? List is also an iterator. Now, if you create 1, 2, 3, 4, 5, this is an iterator. Means you can iterate over these objects. Okay. There are more things, what you can do with custom iterators, but I think this much is enough, to start with. There's also an iter object. There is also a next object underscore. If you don't want to use this next underscore, you can just use underscore underscore next underscore underscore. It's also like this is same as this next. Okay, and these are known as these underscore underscore and before the name and underscore underscore after the name. These are special functions for any class. Okay, these denote these are special functions. Fine. So I think this much is enough for today. Okay, let me once stop the